Well, thanks. I'm Dave Sterlace with ABB. We're going to great information from Patrick there, and I'd like to move us above agriculture and hunting, maybe a little more. So we'll talk about some things we can do there, and of course the information from Kevin was also very good. Basically, I'm going to talk a little bit about the future and where we think the industry's headed. So right now, you know, from yesterday and the edge, we know that the structure of the whole market is changing. How we're able to serve the market's changing. At some level, it's becoming more industrial. We're working with, and we all read the same headlines. You know, Google's doing 140 roughly megawatt build outs at a time using transmission level voltages, you know, 200 kV, things like that. Apple's got a 225, 230 kV site in Denmark coming. So really, really heavy industry, you know, type voltages and power loads coming in. There's some benefits of that, of course. The scale of the infrastructure we're seeing, I think we're gonna, it's hard to tell, but we think we're seeing certainly very large scale data centers, and now with edge and with things like the little data center in a box solutions that we and other vendors have, there's gonna be a real big polarization in terms of scale. Software-driven infrastructure, so we're trying to scale the power like we can scale the IT loads, things like that. Some trivia, do you know why data centers were so cold in the past? Tape drives. So the tape has to be kept cold, otherwise it starts to degrade. That was the real reason we're at the 10 degrees in all the data centers. And it just kind of stuck around as a legacy practice. It really didn't have much to do with the servers themselves. Similarly, do you know why most UPSs have a 8-minute time span on them? Warranties on batteries. So if you cycled them closer than 8 minutes, you avoid the warranty. Now with coming technologies like lithium ion, do we worry? You know, you can short cycle lithium ion all you want. You don't have to charge it all the way up. Get a lot more cycles about it. Yes, there are some safety concerns and some fire code concerns, but certainly there's some interesting things that is coming, and that might allow the data center to play a little differently in the market. I think, to Patrick's point, we can learn from all these other industries. We're behind as far as I'm concerned as well. Look at what they're doing in semiconductors, food and beverage, all the other places. Pharmaceuticals is one of my favorite. The real reason is when they decide to make a new drug, they don't start with the building and come in. They start with, we're going to manufacture this and build out. The building fits what they're going to manufacture there. They can't afford to try to fit things into existing spaces and work from a square design. They really design the building around the process. And that's something that we're starting to see a little bit more in data centers as well. So I think there's some interesting things happening there. And just in general, we've had connected devices forever. We're an industrial control company, among other things. And we've got over 70 million installed connected devices now, and 70,000 DCS systems around the world. So this is all this digital information. This is already happening. It's already there. So what does digitalization do? And we talked a little bit yesterday in the Edge seminar. If you're here for that, I think the important is the dashed line around it. It's everything has to be cybersecurity. If you look at things like Modbus and Profibus, they were designed for closed loop, in-house, not a lot of security designed into them. Now we have to keep that in mind when we look at these protocols and how we can keep that safe and secure. But in general, the first steps toward digitalization are first make an analog signal digital, right? Then collect it, aggregate it, then analyze it, and then finally act upon it, do some things different. I think that's really the key to all this stuff. And that's a simple way to do it. Then you talk about the edge. We talked about the edge yesterday, again, just to rehash some things. Wireless, you know, what we all carry a digital tether, right, in our pockets. What's this thing good at? Is it good at networking? Not particularly. Is it good at storage? No, not really. Is it good at compute? No, but it's a nice little window. So because of that, we need to have some sort of edge presence to support what we need here, and especially video, things like that. YouTube right now is accepting, I don't even know who can put this out, 8K and 12K video. Imagine how much data 8K and 12K video uses. Has everybody seen a 4K TV and how tremendous they are? Imagine 8 and 12. It's coming. And imagine what that could do in industrial processes, in quality control, in manufacturing. Could probably change things around quite a bit. If you go back 50 years to that picture of the GTO, and you go back 50 years to the picture of ABB or anybody's switchgear, it probably looks very similar, right? They have gray boxes filled with stuff. They're big, they're heavy, they're dangerous. They got the lightning bolt on the front saying don't open the door, right? Well, we've actually done something about that. Now, I'm not saying the switchgear is digital, but how we deal with the control of the switchgear is. And we divided into 3 layers of how you do it. The first step was just to replace the voltage sensors and the current sensors with a process signal, okay, a process sensor. We found out in medium voltage switchgear, if you looked at the transformers just for the sensors and protection, for current and voltage, we have 5,700 variations in a typical factory. By going to these process sensors, we now have 7.